Finding probability with tree diagram. It is very effective tool and we have been using it for a long time. Especially for junior classes, tree diagram is the one which solves most of the probability questions. Here is one which is actually meant for senior students. Now read the question and then pause the video, try to answer it, and then look into my suggestion. You'll realize what I'm trying to say. The question here is, a bag contains 6 red marbles, 4 blue marbles. Sarah picks a marble at a random from the bag, replaces it, then picks again at random. Draw a tree diagram to represent this situation and then find the following probabilities. The two probabilities which we need to find here is probability that she gets 2 red marbles, and second is probability that at least one of them is a blue marble. Okay, now let's go a bit slowly and try to understand the question. So a bag has 6 red marbles. Let's say 6 red marbles have 1, 2, 3, 4, 5, 6, and it has 4 blue marbles, right? So let me say 1, 2, 3, 4, right? So that is all there in our bag. Now, so when we are trying to pick anything from this bag, then we realize that this bag is like shaken up, right? So this is kind of a bag was just shaken up, so they get really mixed up. Now Sarah picks a marble at random. So what is the probability of picking red, or what is the probability of picking blue? Let's try to figure that out before we get into details. Now probability of picking red from this is, since there are 6 red marbles, so 6 out of, total is how many marbles? 10. So 6 out of 10, or we could write this as 0.6. Now what is the probability of picking blue from here? So probability of picking blue in this case is 4 out of 10, right? 4 out of 10, so I can write this as 0.4. Is that okay? So that is how we get individual probabilities just for the first pick, right? Now let's look into the tree diagram and get into the details of how to solve this problem with the help of a tree diagram. Now, so the case is that let's make a pick here. So let's say there are 2 possibilities. When Sarah picks up a marble, it could either be red or blue, right? So it could either be red or it could be blue. Now let's first complete the tree and then we'll write down the probabilities in it, right? Now again, if she picks up, let's say in the first draw she gets red, and then again this has been replaced. Since it is replaced, it is a case of independent probability, right? It is a compound probability. So let's understand what case we have. So we have compound probability because there are 2 events happening. So we have compound probability, right? And second thing is it is independent. Why is it independent? It is independent since she replaces it, then picks. So the word replace shows that it is independent. So let's try to review and understand what we are going through. Now again, she picks up another marble, right? This is after replacing. Now it could be either of the 2 situations. That is, if she had picked red first and then again she picks, it could be red or blue, right? Since there are only 2 types of marbles here. So it could be red or blue. So these are all the combinations. Now in junior classes, what we used to do is we used to write this as RR here. So these are the outcomes, right? RR, and this case is R and blue. Let me use blue ink for blue, right? R and blue, and this is blue and red, right? Blue and red, and then we have blue, right? Blue. So these are the outcomes which we have, right? Let me write outcomes here. Okay, so these are all possible outcomes. Are these outcomes equally likely? That is the question. Well, since the number of marbles is not the same, these are not equally likely. That is most important to understand. And these outcomes are not equally likely. Not equally likely. They're not equally likely. It's not like tossing a coin, because in tossing a coin you have only 2 combinations, head or tail, right? So probability of getting head is half, not 0.6 or 0.4. Probability of getting tail is also 0.5 or half, right? So they are equally likely. In this particular case, we get 4 combinations. Remember, these are not equally likely. Therefore, when we say what is the probability of getting 2 reds, the answer should not be 1 out of 4, because 2 reds you get 1 and there are 4 possible outcomes. So if you see it from that angle, you may rush to write down your answer as 1 out of 4, which is going to be wrong. Do you see that? So it is not that, since these probabilities are not equally likely. So this is kind of most important thing to understand, and this is what I wanted you to understand for this. So what is the probability then? Well, let's figure out what is the probability. So we'll have another column for probability, right? So how to find this probability? That is what we're trying to understand with the help of tree diagram and probability question, which we have on hand. So let's go straight from the beginning. Till now, whatever we have drawn, that is called tree diagram. Okay, so this is the tree diagram for us, right? So we have done the first part, that is tree diagram. Now let's put the probabilities in it, and then we say combination of probability and tree diagram. Do you understand that part? Okay, now at this moment, what is the probability of getting red? Probability of getting red is 0.6. So we'll write 0.6 in this branch. Do you understand? That is all. Let me move this sheet a bit in front. Okay, so 0.6 is probability of getting red. What is the probability of getting blue? For getting blue, it is 0.4. Now we are interested in 2 reds. That means we want to go through this branch, right? So next, again, what is the probability of getting red? Since the piece was replaced, it is again 0.6, right? So here again it is 0.6. So 0.6 is the probability of getting red. So the answer for 2 reds is what? It's red and red. So since it is AND operation, right? Red and red, they get multiplied. So what we get here is 0.6 times 0.6 or 0.6 squared. Do you see that? So that is your answer, or which is equals to 0.36. So probability of getting 2 reds is not 1 out of 4. It is 0.36. Is 36 over 100. Do you understand? That is what the probability is. So probability of getting red here is, you can say 36%. So in percent I can write this as 36% is the probability of getting 2 reds, right? Now part B of this question is, I hope you understand that part, right? So when you do this, this is AND operation, right? 2 reds, that means and therefore we get this answer. You multiply them, okay? Now second part, probability of at least 1 blue. At least 1 blue, you have seen these 3 cases are at least 1 blue. So what we can do here is, we can multiply all these probabilities, add them up. At least means combination. So this question is basically OR operations, right? So this is AND operation for us, and this is OR operation, right? At least 1 blue, right? That is what it is. Now that is one way, that is you can multiply these probabilities. And remember, I can just fill this up, 0.6 for getting red and 0.4 for getting blue, right? So what is the probability of getting red and blue? We'll multiply 0.6 times 0.4. So it is 0.6 times 0.4. Probability of getting blue and red is 0.4 times 0.6, and probability of getting 2 blues is 0.4 times 0.4, right? So we can multiply these 3 and add them up, correct? And add them up. Since it is odd operation, right? You get a probability. So that is the way to find answer for B. But there is, some of you must have noticed by now, another method to do it. Now if when you add all these probabilities, you should get 1, correct? 1, right? So that is what you should get. So you can do this calculation yourself, that is 0.6 times 0.4, which is 0.24, then again 0.24, and then add these. So 0.24, 0.24, and 0.4 is 0.16. When you add them up, you get what? 10 and 4, 14, 4, 1. So 5 and 1, 6. So 0.64. So you get 64% as your answer for this. Right? This is one way of doing it. Can you suggest me another way of doing it? Yes, of course. And that is, at least 1 blue means all these cases except for one, right? So that means we are interested in all the cases here except for one, right? So total, as we know, should be 100% or just the number 1. So for at least one, what we can do? Can you suggest now? Yes, we can write 1 minus probability of getting 2 reds. That is at least one blue, right? So we could write this as this, correct? So that means we can write this as 1 minus 36% or 0.36, which is 1 minus 36% is 0.64, right? So that gives us the answer 64% for part B. Do you see that? So that's an alternate way of doing it. I should say that is the main way of doing it. Let me write alternate here. Well, from this example, we learn a couple of things. One, let's understand. It is a compound probability case with independent, since the marbles has been replaced. And therefore, when it is replaced and we are talking about 2 reds, we just multiply the probabilities of 2 reds. And when we are talking about at least one blue, we found that there is a shortcut method. At least one blue means all cases except for those in which there are no blues, right? So there is only one case where there is no blue, 2 reds. So 1 minus 2 reds gives us the answer for part B. So that helps us to give quick answer just by doing one calculation, right? So that is probably the best thing you've learned here. Second, you now know how to use a tree diagram to find probability in such cases. And it's a very effective tool, you must have realized. And you must have also realized that when you make a tree diagram, don't just jump to the conclusion. Remember, you have to ask yourself, are these outcomes equally likely or not, right? In this case, they are not. As you can see, their likelihood is different. 2 reds is 0.36, red and blue is 0.24, correct? So that is how they are all very different. And the difference is mainly because the number of marbles are different, 6 and 4. They are not 5 and 5, and therefore you should not be expecting them to be equally likely. I hope you get them all together, and we'll have few more examples like this. And as a practice problem, what you can do is you can extend this question. Extend it that Sarah picks 1 second, replaces, and then picks up the third one, right? In that case, what is the probability of getting, let us say, 3 blues, or you can say 2 blues and 1 red, and then do for yourself what answers do you get, right? So you can think about similar questions that will help you to practice this method. Thank you and all the best.